A practical investigation using a colorimeter to determine the amount of chlorine in a sample of pool water taken from Lisnagalvan Leisure Centre. You will need to collect all of the apparatus needed for the investigation. This includes test tube racks, 7 clean test tube, 1 10 ml graduated pipette and a pipette filler, 2 beakers, 1 for the deionized water and 1 for your stock chlorine solution, 7 cuvettes and DPD tablets. The DPD tablets will react with the chlorine to give it its colour, a couple of rubber bungs and labels. Step 1 of the practical is to correctly label your test tubes. The labels should be 0, 1, 2, 3, 4, 5 parts per million. These test tubes will contain the different known concentrations of the chlorine. For example, 1 is 1 part per million chlorine. The last test tube is for the swimming pool sample. Label 1 beaker with deionized water and collect the water from the dispenser at the back of the lab. Label the other beaker chlorine and half fill the beaker with the stock solution of chlorine. The concentration of the stock solution is 5 parts per million. This table indicates how much of the chlorine solution and deionized water you need to put into each test tube so that you get a range of known concentrations for chlorine. For example, to make up a 4 part per million chlorine, you will need to pipette in 8 milliliters of the stock chlorine solution and 2 milliliters of water. Secure the pipette filler to the top of the pipette, making sure that it is a tight fit so that it does not fall out when you lift the pipette. Before you actually start to pipette out the water and the chlorine, it may be worth your while to practice pipetting. To use your pipette, apply your thumb to the roller and use steady pressure. Move the roller vertically. Remember to keep the bottom of the pipette in the liquid while you are doing this so that you do not get any air bubbles. Do not try at this stage to fill the pipette to the exact mark, as when you lift the pipette out of the liquid, the level will fall slightly. Instead, bring the liquid level above the graduation mark, move the tip of the pipette out of the liquid and gently turn the roller in the opposite direction until the meniscus is on the line. Remember, the meniscus must be exactly on the line for accuracy. You need to hold the pipette at an angle against the test tube when dispensing the liquid. Once you are happy with your pipetting technique, pipette the water first. This will reduce the error of cross-contamination. Pipette out the volumes of water indicated on the table into the labelled test tubes. 10 ml of water into test tube labelled 0 parts per million, 8 ml of water into test tube labelled 1 part per million, 4 ml of water into test tube labelled 2 parts per million, etc. Next, repeat the process with the stock solution of chlorine. You will find that the volumes go in the opposite direction. For example, 10 ml of chlorine into test tube labelled 5 parts per million, 8 ml of chlorine into test tube labelled 4 parts per million, and so on. Take your time when pipetting. It is important that you make up these solutions as accurately as possible so that you obtain a valid set of results. The process is the most time consuming, but it is worth doing well. Finally, pipette 10 ml of swimming pool sample into the last test tube. Remember, if you've been accurate in your pipetting, all test tubes will contain exactly 10 ml and therefore the levels should be similar. There may be slight variations if you have not used identical test tubes. If the liquid levels are not similar, then you need to seek advice from your tutor. Carefully remove the DPD tablet from the silver foil and place one tablet in each test tube. Allow the tablets to fully dissolve. You may speed up the process by placing a rubber bung on top of the test tube and shaking the liquid inside. Once all of the tablet has dissolved, you should notice a colour change. The deepest colour should correspond with the 5 parts per million, which is the most concentrated solution, and the weakest colour will be the 1 parts per million. The 0 parts per million should have no colour, as there is no chlorine in the test tube. Looking at the pool sample, you should now be able to estimate the chlorine concentration in the swimming pool water. Using a Pasteur pipette, transfer each of the solutions into a clean cuvette. Fill each of the cuvettes to 75% capacity. Remember to use a different pipette for each of the solutions to reduce the risk of cross-contamination. Do not label the cuvettes, as the labels may interfere with the light beam when you place them into the colorimeter. Turn the thumb wheel at the side of the colorimeter to select the appropriate wavelength. The correct wavelength for this colour is 520, and you will see the number in the clear window above the cuvette holder. The colorimeter can measure either absorbency or percentage transmittance. For this practical, you need to be measuring absorbency. Press the ABS %T button to select the absorbency mode. Make sure the ABS is indicated on the screen so that you are taking absorbency readings. Some cuvettes have ridges on the side. Hold the cuvette on the ridge side so that you do not get any marks on the clear side where the colorimeter is taking the readings. Do not place the cuvette in the colorimeter with the ridge side to the front. This will greatly affect your readings. When placing the cuvettes into the colorimeter, ensure that the clear sides are facing forward. Place the 0 parts per million cuvette into the colorimeter. Press the OR reference button. This is important as it informs the colorimeter of a reference sample. This means that the colorimeter knows that this sample is 0 and all other readings will be based on this. Next, place the samples in the colorimeter one by one. To find the absorbency readings, you now press the T for test button. An example of some of the readings are as follows. The 1 part per million chlorine indicates a reading of 0.10 on the screen on the colorimeter. The T button indicates that the 2 part per million has a reading of 0.13. 3 parts per million indicates 0.20. 4 parts per million indicates 0.36 absorbency. 5 parts per million indicates 0.69 absorbency. The swimming pool water indicates 0.10. We can now hazard a guess that this pool sample is about the 1 part per million, but you need to construct a graph to get a more accurate answer.